Hello student, today I am going to solve the heat equation with source. Okay. So here you can see the differential equation, partial differential equation ut equal to uxx with qx. So this qx part is the source. Okay. And here the source qx is given by the function sine 3 pi x, and also the boundary conditions u the boundary conditions u0 comma t, okay, equal to 0 and u1 comma t equal to 0. These are the boundary conditions, and one initial condition u x0 equal to sine pi x. So here you can see this qx is the source part. Okay, so this partial differential equation is not homogeneous. So we can say, like, since this PDE is not homogeneous, so we have to choose the solution. We have to take the solution of this partial differential equation, the two part. One is the time independent solution and other is the time dependent solution. Okay. So in that case we have to choose the solution uxt equal to vxt plus h of x. So this h of x is time independent solution. It is also called steady state solution. Steady state solution. Okay, and this part is known as time dependent solution. It is called the transient state solution, transient temperature distribution. Okay, so firstly you have to solve this partial differential equation for hx. Okay, so the time independent means the u is not a function of t, so the ut part will be 0. That means the h is given by hxx plus qx. Qx means this is sine 3 pi x equal to 0. With the boundary condition, you have to choose only the x part. That means this is h of 0, this 0 from here equal to 0. And another condition at 1, h of 1 equal to 0. So in the first stage we have to simplify this differential equation. This is direct integration based differential equation. So you can integrate once. So this is h of x equal to the sign becomes negative. So I think this is 1 over 3 pi of negative cos 3 pi. So we can write directly, plus c1 is also here, and by integrating one more time, this h of x equal to 1 upon 9 pi, and this is sine 3 pi x plus c1x plus c2. So here there are two parameters, c1 and c2, and by using the boundary conditions we have to find the c1 and c2. So let's put s0 equal to 0. That means we are putting x equal to 0. So by putting x equal to 0, the left side is 0 and this 0. So this gives c2 equal to 0. I think this is quite easy. And h of 1 equal to 0, this means when you put x equal to 1, so this becomes sine 3 pi, and sine 3 pi we know this is 0, and c1 plus. So finally we get c1 equal to 0. That means the steady state solution hx equal to this is pi squared. Okay, so 1 over 9 pi squared sine 3 pi x. Okay. C1 and C2 both are 0. Now see, we have to write this differential equation in the term of v. Okay. So the differential equation in term of the v is given by v of t equal to v x x. Okay. And the boundary condition will be like v0 t equal to 0 and v1 of t equal to 0. And another condition, v initial boundary condition vx0, initial condition not boundary, initial condition equal to u x0 minus h of x. So you can see this one, this is from here. So when you put t equal to 0, you will get vx0 and ux0 and hx will go in the other side. Okay. So this is the new partial differential equation, that is the homogeneous differential equation. Okay. So by using the separation of the variable, we can find the solution of this differential equation. Okay. So let us take v xt equal to capital X. X is the function of x and t is the function of t. And when you differentiate with respect to t, so only t part will be differentiated, and when you take a differentiation with respect to x, then you will get only differentiation for x. So this differential equation becomes like x t prime equal to x double prime t. Okay. So by separating the variable, we can write x double prime over x equal to t prime over t, and let us choose a separation constant negative lambda squared. Okay. So the boundary value problem in term of x will be x double prime plus lambda squared x equal to 0, and we have to take care for the boundary conditions as well. So see, the x is 0 and x is 1. That means the boundary condition in term of x is x0 equal to 0 and x1 equal to 0. Okay. And another differential equation will be for t, so that is the secondary part. Okay. So see this, the solution of this differential equation we know by constant coefficient. So x equal to, we can write a times cos lambda x plus b times sin lambda x. So by using the boundary condition x0 equal to 0, okay, so when you put x0, that means x equal to 0, so you will get a into cosine 0 is 1 and sine 0 is 0. Okay, so into 0 equal to 0. So this is quite obvious, a will be 0. Okay. Now by using the second condition x1, so the a is 0, that means the first part is gone. So x1 equal to 0, this gives b times sine lambda equal to 0. Okay. So you know the b cannot be 0, because if you put b equal to 0, so the capital X will be 0 because a is already 0. Okay. That means v cannot be 0, and if v cannot be 0, then sine lambda must be 0. Okay. So when you put sine lambda equal to 0, that means lambda is some n pi. Okay. So n pi, where n is the positive integer, you can take n equal to 1, 2, 3. That means the n equal to 1, 2, 3, and so on. So this lambda is the eigenvalue. Okay. Now the eigenfunction is xn of x equal to sine, I'm just writing the normalized form, sine n pi x. Okay. And you can consider the t again, the differential equation for t. You can see this part t prime over t equal to negative lambda square. That means this part will be t prime plus lambda squared t equal to 0. So from here the t of t will be some constant. Let's take some constant c e to the power negative lambda square, and lambda is known, so you can write directly n square phi square times of t. That means the solution for the v is vxt in the form of the Fourier series, this sigma n equal to 1 to infinity, let's say some vn, coefficient vn, and exponential power n squared phi squared t sine n pi x, sine n pi x. So by using v of xt equal to sigma n equal to 1 to infinity bn, the constant vn e to the power negative n squared pi squared t into sine n pi x. Okay, so by using the initial condition vx0, okay, so by putting x equal to 0, we will get Fourier sine series, okay, because when you put t equal to 0, so exponential become 1. That means this is vn sine n pi x, and you know the vx0 is what? This is ux0 minus hx, okay, equal to sigma n equal to 1 to infinity bn sine n pi x. So you know the ux0, it was sine pi x, and minus 1 over 9 pi squared sine 3 pi x. Okay, so you have to open the summation. So when you open this, because the eigenfunction is similar than the sine pi x and sine 3 pi x. Okay, so you can open the summation. So you will get v1 sine pi x plus v2 sine 2 pi x plus v3 sine 3 pi x plus test. Okay, so when you compare, so see the sine pi x, so you can see the v1 is 1, v1 is 1, and there is no sine 2 pi x term in the left side, so v2 equal to 0. Okay, and sine 3 pi x is there, and sine 3 pi x is there, so b3 equal to minus 1 over 9 pi square. So you can understand rest of the v, all of them are 0. Okay, so we get two non-zero b, b1 and b3. Then the vxt will depend on the only in the 2 part. Okay, So now let's finalize the solution, or you can write the bxt separately. Okay, so the bxt is for n equal to 1. Okay, so this is exponential power n is 1, so this is only pi squared t into sine pi x, and v3 is, that means exponential power 9, because n square is there, okay, 9 pi squared t sine 3 pi x. Okay, and before that it is 1 over 9 pi square. So this is the vxt, but your final solution is uxt. Okay, so you know the uxt is what? Uxt is uxt equal to vxt plus hx. Okay, so we have hx we already find in the other part. Hx is this. Okay, so 1 over 9 pi square sine 3 pi x. So when we put this hx, so uxt is equal to, I'm just putting hx, so this is 1 over 9 pi squared sine 3 pi x. Okay, so this is the time independent term. This is because of q. Okay, and plus the rest of the term. Okay, so the first term is minus exponential power pi squared t into sine pi x, plus one more term is exponential negative before that negative, I think 1 over 9 pi square is already there, negative. Okay, so the next term is the negative 1 over 9 pi squared exponential power 9 pi squared t into sine 3 pi x, sine 3 pi x. So this is the solution for differential equation, partial differential equation with source. I hope student understand the solution. Thank you.